Akta, the new way to sign and store your data securely on the blockchain. Akta leverages the power of the Ethereum blockchain and the IPFS network to securely sign and store your documents. The hash of your document is stored on the Ethereum blockchain, while its encrypted contents are stored on the IPFS network. You can learn more about both the Ethereum blockchain and the IPFS network by following these links. As a general overview, Akta is a fully decentralized application, with no one but you having access to your documents. You can use Akta in one of two ways, either as an e-sign tool or as a general storage tool. In this video, we will show how to use the e-sign functionality of Akta, while in the next video, we will demonstrate its storage functionality. To get started, we log in. And next, we'll be prompted to connect our Ethereum account to Akta. If you don't have an Ethereum account, you'll have to create one in order to interact with Akta. Akta runs on a smart contract on the Ethereum blockchain, and every transaction requires you to have an Ethereum account. Once you connect the account, you will be prompted to install the MetaMask browser extension. MetaMask is one of the more popular ways to interact with the Ethereum blockchain through your browser. You can download and install MetaMask at metamask.io, and it is available for the following three browsers. Once you have downloaded and installed the MetaMask browser extension, you'll go ahead and unlock it by entering the password that you set up when you downloaded and installed MetaMask. Next, it will prompt you to connect to the Akta smart contract, which you will allow. And next, it will ask you to sign to generate an encryption key for your documents. This is so you're able to view your profile information, which is encrypted. Once you sign, you will be forwarded to the main page of Akta once it is unlocked, where it will list all of your documents. Currently, there are no documents in this account, but that will change shortly. Before we go ahead and upload the documents, one thing to take into account is that MetaMask is in the Ropsten test network. This is very important because Akta is currently uploaded only on the Ropsten test network. In the near future, it will be uploaded on the mainnet as well, but currently it is only on the Ropsten test network. Another thing you will notice is that here I have some test ether to interact with Akta. In order to get some test ether for the Ropsten test network, you will need to go to one of the many faucet sites for Ropsten. I personally used faucet.ropsten.be to get my test ether when interacting with Akta. Once you have the test ether, you're ready to upload your document. In order to use the e-sign functionality, you first have to provide some profile information. This is needed so that the signee will know who is sending them the document. So here, we will enter some generic profile information for demonstration purposes. Once we have entered that information, we click Submit, and we'll be prompted by MetaMask to interact with Akta because we're uploading this information there. This information will be uploaded to the Ethereum blockchain in Akta in an encrypted way so that only you have access to it, and only the people you send your documents to will know who is sending them the documents. The upload of this information generally takes between 15 to 20 seconds, depending on the speed of the Ropsten test network, which varies with time. The transaction has been mined, and we can here see the test information that we entered. Now we are ready to upload the document. So once we go back to the home page, we click on Add, and we select a sample PDF file we have created to demonstrate the eSign functionality. Note that for eSign, currently, only PDF files are supported. We will send this document to a sample user that we have created for this demonstration's purposes. Note that we can add more users if we wanted to, but for this demonstration, we will limit ourselves to just one user, one signee. Here, we will enter the title of the email and the body of the email that we will send to the users. Once we're ready, we'll click on Upload, and here we can drag the signature, initials, and the date boxes to the place in the document where we want our user to sign an initial and date. Once we're satisfied with the layout of the document, we click on Upload. We will name this Secure Test Doc. And we will sign this document. By signing this, we're generating the unique encryption key, which will be associated with this document. This will make sure that only us and the signees will have the encryption key to read this document. Now, this document is being uploaded to the IPFS network. Depending on the speed of the IPFS network, this process can take between 1 to 2 minutes. Once it gets uploaded to the IPFS network, we'll be prompted to upload the hash of the document to the blockchain, which we'll go ahead and confirm. And the transaction is finished, and the email is sent to our intended recipient. Once we check the email for our recipient, we will see that we received this NDA agreement and a short message by the sender. Here we are in the signature page, and we'll go ahead and fill our information. And we'll click on the document to fill it out. Finally, we will upload the document on IPFS again with the new information that we have just filled out. Again, this will take between 1 to 2 minutes, depending on the current state of the IPFS network. And here we have successfully signed and re-uploaded a document to the IPFS network. And we have received an alert that Jack Smith just signed the document. We'll follow the link to verify the document. As we can see here on the home page, it shows that the document is waiting to be verified. Once we click on the document to verify it, we first have to regenerate the security, the encryption key to view the document. And we see that our user, Jack Smith, has successfully signed and initialed and dated the document. So we'll go ahead and verify that everything looks okay. This is another transaction with the Ethereum network. And another 10, 15, 20 seconds or so, this will be mined. And the document will be signed. And it is already mined. If we go back to our home page, we'll see that the document has been successfully signed by Jack Smith. And this is how we can use the e-sign functionality of Akta to securely sign your documents with the power of the blockchain and the IPFS network. Note that, again, no one except for you and the intended receiver has access to this document, as every step of the way is encrypted. Thank you for listening, and if you want to check out how to use the general storage functionality of Akta, make sure to click for part 2.